So today is just kind of our review day, right? So if we have questions on things, happy to do that. If you wanted to walk through the test review, I think we mentioned last time that that was up. And the format for the test review is the same format for your exam. We kind of talked about that last time a little bit, didn't we? Okay. So I'm not going to talk about exam format then. I'm just going to open up for questions and let you guys pepper them away. And we'll knock those out. When you guys are done with me, you can work on your stuff and I'll leave you alone. Victoria.
Could you do number 3 on the review?
Sure. Grab that. That. And give me that. All right, 3 from the review. Says confirm that y equals log of 5x cubed plus 2 is a solution to the first order differential equation y prime times 10 to the y equals 15x squared over the natural log of 10. So my goal here is I'm going to use my solution, plug it in here, and see that it gives me this, that makes the two things equal. So to plug in here, I need something for y prime, but I have y. So I'm going to start by finding the derivative of this. So how do I do, what do I need to do the derivative of the log of 5x cubed plus 2? Separate what?
No.
So we're doing a derivative, not an integral. So u sub is the wrong thing to say. What? Chain rule. Great. So the derivative of the outside is the derivative of log, which is the insides times the natural log of why 10? That's the base of the logarithm, right? The reason we don't get that extra when we do the derivative of natural log is because you'd have the natural log of base e, which is just 1. So it just goes away. Okay? But that's not all. What else do we have? Times the derivative of the inside, which is 15x squared. Okay? So if we take the left-hand side of that equation, y prime times 10 to the y, we have 1 over 5x cubed plus 2 times the natural log of 10. It's supposed to be 1 over the natural log of 10. I think it is. Right? Let me grab that real quick. You guys. They're back at the end. Reference pages. That's what I'm looking for. Oh, hello. Thank you.
You're welcome.
There it is. Yeah. So just to remind you guys, it's 1 over the natural log of 10 there. So don't forget that stuff. Oh boy. So we'll just fix that real quick. Looks like that's not going to work out the way I need it to. So that's all the derivative, and then I have 10 to the log 5x cubed plus 2. Everybody's okay there? So what do we notice happens? Exponent base 10 cancels log base 10. And I'm going to put these two together because looking to where I'm going, I should have those two guys left over. And if I look, hey, look at that. Those will cancel. And what's left?
No problem.
Yep.
So that's it. We don't have to circle anything.
Correct. You're just showing me the work on how to do it. Confirming means show, right? Is synonyms enough?
Yeah.
Yeah, go ahead, Victoria.
So for number 4 and 5, like that's all you want us to do for those if those are on the test.
4 and 5 are just things you do with your eyes. So there's not much to do. You just draw your picture and then you just write down the equilibrium solutions.
And for 5, all you want us to do is so equilibrium means where it goes straight.
Where it's horizontal, where the derivative is horizontal.
Even if it.
So you're looking for values of x or y where the derivative is flat. Yep.
Okay. And all you want us to do is x equal 1, x equal 3. That's it.
That's fine. Yep.
Okay. I just feel like it's too easy to be.
No, man, it's okay.
Okay.
Victoria?
Number 6 on the review.
Okay. Okay, so it says to solve the differential equation. So I'm going to start just by rewriting the y prime as dy dx. And the first thing I'm going to do is check to see if this is separable. Can I get the x's on one side and the y's on the other? And it certainly seems that way, right? If I divide both sides by tangent, and multiply both sides by dx, I've got that separable. So far, so good. Okay. So then we'll go ahead and integrate both sides. Oh, I made a boo-boo there. I wrote down tan x, that was supposed to be tan y. I just copied it wrong. Okay. So, how do I do the integral of tangent, or 1 over tangent? Do we know an antiderivative rule for cotangent? That's the same as 1 over tangent. I don't think we have one, do we? So what should I do? Okay, so cotangent is the same thing as cosine over sine. And that looks like something we can u-sub. So if I say sine is equal to y, du is going to equal cosine y dy. So using that, I have 1 over u du, which is something we can definitely do an antiderivative on. What am I going to do with the right integral? X plus 1 over x. Yeah, very good. So just keep it simple. Since the denominator is a monomial, I can just break that into 2 fractions with a common denominator. So I can just write that as like 1 plus 1 over x dx. So I have then the natural log of the absolute value, sine y, equals x plus the natural log, the absolute value of x, plus c.
Plus C, okay. You did plus
Well, for a minute anyways. What else was I given in this problem?
Y.
An initial condition, right? So I'm going to use that initial condition now to solve for c.
Oh, okay. Would these be like from 9-3?
Uh-huh. Yeah, that's what this is. All right. So we have x. This initial condition tells us x is equal to 1 and y is equal to pi over 2. So that's what I'm going to be plugging in down here to solve for c. So if I go to my unit circle, what is sine of pi over 2? 1. What is the natural log of 1? 0. And the natural log of 1 was 0. So we have c is negative 1. Oh my gosh, guys. Oh no, that's fine. Did I just make a mistake on there? Sure did. That's okay.
Did you make a mistake on the?
Yep. Yeah. I plugged a x or a y value into my x, which is pretty dumb. That's a Mr. Kulik level mistake, right? Make a note for that. It's what, number 6? Okay. So that should be your answer. Is that okay, Victoria? Amanda.
Can you do number 7? I'm just confused
Yeah, sure. Oh, that's because what I solved and what I wrote were two different things. So that's the problem here, Amanda. So I solved this one. I wrote down this one. Let's do both of them though right now. Sound good? So again, these are separable. So I should have, with the one that I typed, multiplied both sides by y, and then multiplied both sides by dx. And this one I would have divided both sides by y and multiplied both sides by, still have my x here, and multiplied both sides by dx.
So is the red what you did on the
So what I'm saying, Victoria, is that the work I put on the key was for the problem in red.
Okay.
The one that I typed is the problem in blue. I'm going to do both of them right now.
Okay.
So regardless of what you did, here's an answer. And then to integrate the natural log of x over x, we'll just use a u sub.
Why did you do 1 over u?
Oh, excuse me. Thank you. Good. And then we'll just multiply both sides by 2 to get the y by itself here. Now I could write 2c here, but since 2c is still just a constant, I'm just going to call it c. If you wanted, this would be c1, this could be c2.
If you do 2c on the test, would you mark?
No, that's okay. And then we'll just square root both sides. And that's the answer to what the problem that I wrote was. And here we'll just we got to get rid of the natural log around the y. So I'll do exponent base e to both sides. I can then drop the natural log or the absolute value with the plus or minus. I can use my exponent rules to do this. And I'm going to just call all of that C. Or if you wanted to leave the plus minus there and do plus minus c, that's fine too. Either is okay.
I did all of that, and then like I canceled out like the square root because it was squared. Can I do that?
The square root because it was squared?
Yeah.
No,
No.
because the square root doesn't distribute across the addition.
Okay.
Right? Like if I have this, that's not just a plus b, right?
Gotcha.
Which is kind of what you're trying to do there, right?
Mhm.
It's all that algebra. Dur.
Why is it not natural log x squared over 2? Like you didn't, or maybe I'm not looking at something.
Oh, sure. Yep.
Okay.
That sounds good. Thank you, Victoria.
Cool.
Could you simplify that just to c times x squared over 2?
No, and that's a good question, Luke. The reason is that I have that. So the squared is outside of the logarithm. If the squared was inside, like if I add e to the ln x squared, then yes, those could cancel out and just be x squared. If I have this, though, not any simplification I can do there. Is that? I mean, there probably is, but nothing good. Let me think. Well, we also have this divides by 2, so it really kind of complicates the whole thing there. Yeah, I don't think that there's, well, you could, I guess you could do like, nope, that's not what that means. It'd mean this, right? Yeah, there's, I don't know that there's, I mean, you could do that and take that, nope, because that's times also. I don't think there's anything good to do with that, Luke.
Could you do like power rule in that sense? It'd be 2 natural log x divided by 2. That just be natural log x.
Well, here's the thing. No. What you can, I mean, what you could do is if you thought about it like this, you can take those two together and do a power rule on one of them. And do that if you wanted to. But I don't think that's any better. And the good news is, on the AP exam, on a free response question, do you need to simplify it all the way down? No. No. So it doesn't matter. If it can be ugly, unsimplified stuff. You're only going to get yourself in trouble trying to simplify things down. So like, don't go crazy trying to mess with something like that. If you're like, you know what? I got it. Can I simplify this? I don't know, but I don't care because I've solved it. It's got y by itself. Like I'm stopping. Good enough. Check. I don't know. Victoria, are we done with this one?
Oh yeah, I was gonna
Oh, Amanda, you asked about this
Yeah.
though. Sorry.
I'm good.
You're good? Okay. Yeah, I'll make some note on the review here. So this one is, what's this? This is number 7 also. Okay.
just go over every single problem.
I mean, Jack wants a homework book problem question here. So let's take a little break and do that. And we can circle back if you have more stuff though, guys. What's up?
9-5, number 11, sorry.
9-5. number 11. Oh boy, that's really small. You sure anything was actually there, Kulik? All right. Okay, so reminder, first step is I want to get this in that linear form. So I'm going to start by dividing everything by sine x.
Dividing everything by sine x.
Because I got to get that dy dx by itself. At that point, I am in the correct form. So my p of x is here. So to calculate my integrating factor, I'm going to do e to the integral of p of x dx. What's the good news here? That's an integral that we've almost already done, right?
Yeah. Natural law.
Yeah, we did this exact same one right up here, right? Where did it go? There you are. So we know that that's just going to be the natural log of sine x. Is everybody okay with me shortcutting through that, Jack?
Yeah.
Okay. Yes, absolute value also. So far, so good. And here's the thing. What am I gonna, this is the integrating factor, right?
Yeah.
What am I about to do with this? I'm gonna multiply both sides of my equation by this, right?
Yeah.
So if it's negative sine x and I multiply to both sides, or if it's positive sine x and I multiply to both sides, either way I get the exact same thing, right? So what does that tell me? I can drop the absolute values.
Wait, why would it be the same thing negative?
Because I'm going to do it to the same side. What I'm about to do is multiply this to both sides of an equation. So if I multiply by 2, or if I multiply by negative 2, it don't matter. Yeah, it just cancels each other. You know what I mean? It's going to be the same thing. So that's why I'm able to do this. So the left-hand side then becomes my integrating factor times y. So the derivative of that equals my q of x times my I of x yeah, q of x.
The x squared and x doesn't cancel out.
No. Because of the signs that are wrapped around it. But that can cancel out. So we'll integrate both sides. I know from the fundamental theorem of calculus that if I take the integral of a derivative, those things just cancel out and I'm left with the operation, or the function itself. And then I just need to integrate sine of x squared dx. How do I do that? Well, what would you pick as your u?
X squared.
Okay, so the du I need then would be 2x. Do I have an extra x rattling around here?
No.
Or no, sorry.
No, right? So, well, is there two parts to this? Or are there two functions multiplied together? No, so can't do parts. I just leave it as an integral, right? We've seen that that can happen on these problems. That's okay. So the last step is just to get the y by itself. And if you wanted, this answer's fine, but if you wanted to be extra fancy, if you want to write this as a function in terms of x, I can rewrite this using like the fundamental theorem of calculus to write it as a real function of x.
Would we get like one or like half
An extra point? I don't know. You just get a fancy, you just be a fancy lad. Shoot. I think I need to write a plus c here still.
Oh, yeah.
I think I still need a plus c though. Even though I didn't finish doing that integral, I think I still have to put it in there.
Okay.
I'm pretty positive the back of the book's going to have a plus c at the end there.
Okay.
But that's the gist. If you got to the integral of sine of x squared and you weren't sure what to do, that's a good thing because turns out you couldn't do anything with it. So yeah, it's like, what do I do? How do I u sub that thing? Yeah, you don't. Which should make you feel better that you're confused on how to do the u sub for it. Victoria.
Number 8.
Sure.
Because I look at the review, like the key, and it's like I just need an explanation.
Hey, I'm laughing a little bit, but it's fine, you know? Like, I'm going to chuckle to myself that it's like, could have seen this one coming, but that's okay.
I feel like this is like the one that we just did with Jack.
Yeah, it's almost the exact same problem, but that's okay. Let's do it, right? So I need to get, in this case, my y prime is that dr dt. So like r is like my y and t is like my x. So what do I need to do to get that dr dt by itself? Divide by t natural log t. And actually, let me do this. I'll write it that way. Just so it's easy to see, here's my y prime. Here's my p of x. Here's my y. And here is my q of x. Victoria, you happy?
Yeah.
Okay. I should also note that I can cancel those t's there on the q of x. Might as well do that. All right. Next up, let's start by getting that integrating factor, which is just going to be e to the integral 1 over t natural log of t dt. How am I going to integrate that? U sub. Yeah, what should my u be? Natural log t. So du should be 1 over t dt. The antiderivative of 1 over u is just the natural log, absolute value u, and when I plug my u back in, that's going to be the natural log of the absolute value of the natural log of t. Which you look at and you're like, shoot. The good news is you can cancel those, absolutely. So you're just left with absolute value natural log of t. Okay. Now that we have that, I multiply that to both sides. So my left-hand side should be my integrating factor, which again, I'm going to do that same trick that I did before, where I'm just going to drop the absolute value since we're doing it to both sides. If they're both positive, it's fine. If it's both negative, the negatives cancel out. It's not a big deal. And that's lovely because when I do that, the natural log from the q of x cancels out. And now we're cooking with some gas here. So integrate both sides. The antiderivative of e to the t is just e to the t. And then we just divide both sides by the natural log of t. And I think we're good to go. Yeah, I wrote the plus. See, I didn't say that. So that wasn't so bad, right? If you knew what you're looking at, right? Again, the trick was finding that integrating factor. But the formula to do that, I mean, it's just a formula, right? They're all kind of the same way once you get them in that linear form. Yeah. Well, I think Amanda's raising her hand now, so I'm going to call on her. But you can have the one after Amanda. That's okay.
I have like a quick
Okay.
Like, do we have a way to integrate the natural log? I'm forgetting.
No.
No.
Oh.
Or you could just leave it if you're doing the book problem.
And then solve the initial value problem. So I don't know how to do that with the integral.
Yeah. Fair.
So I probably did something. I'm not sure that's-
We can do that problem.
Amanda.
Can you like go over like for 10 feet?
Sure. Okay. So concave up is something like this, where if you think about like filling it with water, it'll hold water. Concave down is something like this, where if you feel like you try to add water on it, it just would like run off. Okay. The derivative, or the second derivative, tells us about concavity. When the second derivative is positive, I think we're concave up, and negative we're concave down. Let me just double check that right quick. I don't want to say it wrong, you know what I mean? Okay, second derivative is positive or concave up and negative or concave down. Okay, good. Whew. Okay with that, Amanda?
Yeah.
Okay. And then you wanted to talk about with respect to 10b. Okay. That's probably enough of concavity review, right? That's what you
Yeah,
needed?
that's-
Okay. So I guess first order of business is going to be just finding that second derivative. I'm given the first derivative, so I guess the first thing I would do is I just distribute that 1/4 through. And then if I differentiate with respect to t one more time, God bless you, I have, well, the derivative of 30 is just 0, and the derivative of 1/4 b with respect to t it's just going to be like negative 1/4 times dB dt. Right? Now, let's do that first. So that's going to just be negative 1/4, and then dB dt is 1/4 times 120 minus b. But what do we know about b in the problem? B is the bird's weight. So I know that B is always positive. I feel like I messed this up, huh? Okay. No, that's fine. And specifically, I know that this now, the second derivative, is got to be negative as long as b is less than 120, right? So this should be concave down as long as b is less than 120. Let's go and look at my picture. Well, sure looks like the entire picture b is less than 100. So we should be concave down the entire time, correct? But if I look, this section is concave up. So can't possibly be the correct graph because this should be concave down the entire time. But it's not. So the graph is just disagreeing with what the second derivative would tell us. Luke? I think so. I don't have a problem with that. 15 from 9.4? Sure. I think this was the one with the immigration thing going on, right? This looks like it's going to be an involved one. I see a lot of words. have a little bit that runs onto the next page, so I have to use 2 separate screen grabs, which is always cool. That needs to be bigger if anybody's going to read that other than me. All right, consider the population P equals P of T with a constant relative birth rate and death rates alpha and beta respectively. Oh, with constant birth and death rates alpha and beta respectively. And a constant emigration rate, M, where alpha, beta, and M are positive constants. Assume that alpha is greater than beta, i.e. more people are being born than dying. Then the rate of change of population at time t is modeled by the differential equation dp dt equals kp minus m, where k is equal to alpha minus beta. Find the solution to this equation that satisfies the initial condition p naught equals, or p of 0 is equal to p naught. Okay? So I have dp dt equals kp minus m. So what I'm going to do is I'm going to set this up as a linear differential equation. So I have dp dt minus kp equals negative m. My integrating factor is just going to be e to the negative, or e to the integral of negative k dt. So that's just going to be e to the negative kt. So I have then e to the negative kt times p prime equals negative m e to the negative kt. Integrate both sides. So the integral just cancels out the derivative part. And to do this, I'm going to have to do a u sub. It's an easy u sub, but I get that. So when I do my antiderivative, I end up with e to the negative kt over negative, it just should be k, plus c. So let's see, I have p equals m e to the negative t over k plus c, and then we'll multiply both sides by 1 over, well, let's just do this. We'll just multiply by e to the positive kt. So p is going to equal m over k plus c times e to the kt. I should go look at this before I get too deep in this here, huh? Makes me a little nervous that I wanted to do it, treat it as a linear differential equation here. Considering that's, now that I think about it, that's 9.5. Oh, okay, so they just did it that way, that's fine.
plus times. Okay. Yeah, that's okay. That's fine. What we did was fine. Didn't need to do it that way, but it works. All right, so then we want, this is P of t. And we want to use then that P of 0 is equal to P naught. So P naught is equal to P of 0, which is M over K plus C times K, or E to the K times 0. So that just is going to cancel out, become 1. If I subtract M over K to both sides, I get there, my constant is P naught minus MK. So that's my answer for part A. Woof! That was a workout, Mr. K. Yeah, I know. Part B then asks, what condition on M will lead to an exponential expansion of population?
Have to be like 0 base population.
Well, I need to make sure that this is a positive number. That's all I need. So for part B, I just need that coefficient has to be greater than 0. So subtract P naught and then multiply by K or negative K. So I should say that M is less than K times P naught. Then C says, on what condition on M will result in a constant population and then also a population decline? So for that, I would need P minus M over K to equal 0. If I do that, then the population just becomes M over K always. And for a decline, P naught minus M over K has to be negative. And I'm not going to solve those because I think at that point it's should be okay, right, Luke? Okay. If it's not, say something, but I have a feeling that's okay. I mean, it's not surprisingly, it's just going to be equals MK, and then it'll be greater than KP naught. Oh, shocking!
So K is your relative growth rate, right?
Yes.
So when you're multiplying that by the population,
The initial
the
population.
initial population, the rate that population increase is going to be proportional to itself.
Well, here's what you want to think about. This is rate times, or I should say, this is a rate of population times a population, right? So it basically says that the people leaving has to kind of be equal to net positive growth in population,
Yeah.
which makes sense if for the population to say constant. Oh, that's all we're saying? That's all I'm saying.
here it says the people leaving has to be more than the net change in population for it to decrease. Oh, well, that makes sense, right? Okay. So just kind of like decoding what this is saying. All right, then it says in 1847, the population of Ireland was about 8 million, and the difference between the relative birth and death rates was 1.6% of the population. Because of the potato famine in the 1840s and 1850s, about 210,000 inhabitants per year emigrated from Ireland. Was the population expanding or declining at that time? So what are we going to do with this? When I read this, this just sounds like I'm going to be plugging in some numbers into what I got. So my initial population was 8 million. My K is the difference between alpha and beta, which is, we're told was 1.6%. I'm going to change that into a decimal. So that's 0.0016. Oh no, too many zeros, Kulik. 0.016. And then we're told M is 210,000. So what am I going to use? I'm just going to look at that and see which one of those relationships hold. And I guess when I do that, I get 128,000. And since that is less than M, I know we're in the declining stage. That was it. The tough one was part A, right? Just getting the thing solved. And if you were sneaky about this, you could have done it without doing a integrating factor. Do you want to see how you could do that? So the trick would have been to factor out a K. So you'd be this, and then you can divide both sides by P minus MK and multiply by dt, and you're good to go. Separated. It just kind of, the integration is kind of a hassle at that point. But that's what you would do. Does that feel okay? So you could have done it that way also. Didn't need to do it this way, or with an integrating factor, but when I looked at it, that's what I saw. That's what I wanted to do with it. But you didn't need to. But it still works, right? You got the right answers. Victoria, what else did you have? Did you have another one? I thought I remember you trying to ask one. I am just floored that that's the one you wanted to ask about. You did like the hardest part of 10, I think.
But since we just skipped to that, I don't know where that came from or why that happened.
Oh, that's dumb. All right. All right. Do you remember Euler's method? No. We better remember it then. Where was that? Was it in 9.1? I thought maybe it was. Yeah. No, I know. I just wanted to like paste it in there so like it's in with it. Is it in 2, you say? Oh, there it is. Euler's method. I just saw it. Where did you go? There you are. That's what I wanted, you little bugger. Bloop. So that's Euler's method. So we're given in the problem the point 1, -1. That's my x0 and y0. And if I'm going from x equals 1 to x equals 2, using 2 steps of equal size, my h is 1/2. That's right. It's nothing sneaky going on there. It's exactly what you'd think. So y1 then is going to be y0 plus h times f of x0 comma y0. So my y0 is -1. My h is 0.5. And then my f of x0, y0 is going to be -1 squared plus 4 times -1 plus 5 over 1.
Do you mind explaining the x0, y0 notation?
Well, if I'm using the formula, if this is 1, 1 minus 1 is 0, right? So it's just like your previous point,
Oh, okay.
right? What are we really doing with an Euler's method? We're trying to take a smooth function, and we're taking some piece of it, and we're going to try to approximate that piece by using little tiny linear segments to like map it. So we have like approximately the same set of points, but we're gonna get them through like a linear approximation. So we're just going from like 1 to 2. We're taking that section of it, the start point. We'll do a line with the same slope as at the start point. Halfway, stop it. Take the next line with the same slope as the end of the midway point, and then draw the rest of it. That's kind of what we're doing. So at that point, it's just calculator time. Let's see, I should be able to do this in my head. That's going to be 2, so that gives me a 0 there. So we have 0.5 comma 0 as my next, as that first approximation. And then y2 is going to be y1 plus h times f of x1 comma y1. So that's going to be 0 plus 0.5 times 0.5 squared plus 4 times 0.5 plus 5 all over, oh, those are y's up there. Whew, I was like, oh no. So my x is, oops, that should be 1.5, right? 1.5. So let's see, 4 times, oh my God, guys, I just did like a massive, oh yeah, those are supposed to be zeros. Thank you.
So for y1, we got that is all equal to 2. What happened to the 2?
For y1, we got it equal to 0. Well, 5 plus, It is 2 times a half is 1 plus negative 1 is 0. Okay. So this is going to be 5 over 1.5 times 5. That's 2.5 over 5, which is 5/3. So that's my approximation there, is 5/3, I think. It's me trying to do some mental math. Okay, then it says to solve the differential equation with the initial condition. So what are we going to do here? We're going to separate this. And then we'll integrate both sides. How do I do the antiderivative of 1 over y squared plus 4y plus 5? Every single one of you should know how to do this. Yeah, I have to do the completing the square with tan inverse. I think this was almost exactly the test question. So I would just think about this as 1 plus y plus 2 squared when I complete the square in the bottom. Can we see that? Y squared plus 4y plus 4 plus 1. And y squared plus 4y plus 4 is just y plus 2 squared.
Where did we add the 1? We added it to 5.
I just broke the 5 up into 4 plus 1.
I know how to do this. I still go.
Okay, so this is my b, right? So to complete the square, I need to have b over 2 squared,
Okay.
which is 4, right? So I got, okay, well, 5 is just 4 plus 1. So if I factor y squared plus 4y plus 4, that's just y plus 2 squared, and I have the plus 1. And I'm done. It's like the easiest completing the square I can almost create. So this is a U sub problem, but it's like the easiest U sub that ever U subbed. So I have then the tan inverse of y plus 2 equals the natural log of x plus c. And my initial condition was 1 comma negative 1, I believe, right? So negative 1 plus 1 is 1. What's tan inverse of 1? It's pi over 4. (45°), which is pi over 4. Yep, exactly right. Natural log of 1 is 0. So I just get that c is pi over 4. And I'm not going to try to get the y by itself because yuccaronis. Victoria, are we still okay? Jillian, you all right?
Yeah, I just don't like those ones.
Icky.
Yes.
Okay. The last one says then, use my answer from part B to find the exact value of y of 2, and then compute the error for your estimate in part A. Okay? So y of 2, that is x equals 2 when y equals something. So we have tan inverse of y plus 2 equals the natural log of 2 plus pi over 4, right? So to get the y by itself, we'll do the tangent of that, and then subtract 2. And I'm just going to go to my calculator and type that in. So when I do that, I get negative 1.97. Oh, you know what? What mode am I in? Degree. What mode should I be in? Yeah, thank you. That makes a heck of a lot more sense. There's your 808. Sorry. 808 or 880? 880. So my error is just going to be y2, I'll put E for exact, minus y2a for approximate. Oh, that's why. Yeah. For whatever reason I did in the key, I guess I did 4 steps, huh? That's odd. I guess I didn't. Whatever. Close enough. So minus 5/3. So 7/14-ish. Is that okay, Victoria? Luke?
I have a question about number 11, 9.4.
Yeah. Let's see. Yes, of course. That's a weird spot to have dropped that. Okay.
So, in order to prove that the second derivative of logistic equation 4 equals that right there, would you just take the derivative of that first logistic equation?
So what I would do is I would actually start with the second derivative equation because it just saves me a step. Because I know this was the differential equation I had to solve to get the logistic. So I'm just gonna, I know that the derivative of p gives me this anyway, so I'm just gonna skip that step. Sergio? Sure. So if we did that, oops. That's a product rule, right? So I take the derivative of the first times the second plus the first times the derivative of the second.
Why? So is P a constant or a variable?
P is the variable.
Okay. And then, so K is.
Oh, wait a minute, hold on. That's not right because we're differentiating with respect to T. Okay, hold on. That's not quite right. So I have K times 1 minus P over M dP dt plus Kp times negative 1 over M dP dt. Sorry. So then I have to drop this guy back in. So I notice that, well, let's start here. So if I can factor out a K and a dP dt from both of these, right? Let's write it as minus P over M. Agreed? This stuff can just combine because they have common denominators. And then I'll just drop back in the equation for dP dt. And then oops. That's what we're supposed to get.
So I'm just confused based off of the derivative notation, the dP, which letters are actually our variables, which are constants.
Okay. So if I think about this like dP dt is kind of equivalent to like dy dx. So like p is like my y, that's a variable, and t is like my x. So the m is a constant, the k is a constant. Everything else is constant other than p and t. And notice there's no t's anywhere in here.
Yeah.
So it's like doing d dx of y. So when I do that, I should get a dy dx every time.
Then, so since this is like regarding logistic equations, K is a constant because that's just the growth rate that'll never change.
Well, yeah, facts, and m is like your carrying capacity, right? That doesn't change. That's constant as well. So the K isn't a growth rate, it's a constant for the rate. So like dP dt is the growth rate. That's the change in population over time. That change in population is proportional to some K. So K is a constant factor of the growth rate. Does that? Okay.
It's just like a general question, but for C, like if you do something to it, do you have to like show that it's a different C, or would you be fine with like just putting C?
Just keep up C's the whole way through. I will not be picky about that unless you had to like keep it there, right?
Okay, yeah.
So like if you had C divided by X and you tried to call that C, that's no bueno.
Yeah.
But C divided by 2, just call it C again. That's
Okay.
fine. No biggie.
Okay, good, because that's like what I've been doing, and then like one of them we were like.
I was just trying. I think because I was writing it out, I'm like, maybe I should like be clear. I think at the end it just turned into C again.
Yeah.
I was just trying to like, I know I'm doing this, and make it so nobody's like, oh, he just didn't do it to this? Why didn't you do it to this? So there's me struggling to how do I best communicate that.